In today's video, we're going to go over how you can get the most out of Kamal for deployments which have been added to the service stack templates. Kamal is a CLI tool that wraps SSH and Docker to improve the ergonomics of self-hosting your application, and our templates have been updated to use Kamal while maintaining GitHub Actions as the CI runner. Kamal is a tool that enables simple commands to deploy your containerized applications to any Linux host, taking care of bootstrapping, reverse proxies, and other configurations that can be tedious and error-prone to set up. It is built by the team at BaseCamp and is maintained on GitHub, for which I'll leave a link in the description to the repository. Previously, service stack templates used SSH and Docker Compose directly, along with the use of an Nginx proxy to host containerized web applications. Kamal takes the same approach but greatly improves the individual developer experience for interacting with those services and applications through their Kamal CLI tooling. Today we're going to walk through how you can create a new Blazor project using the Service Stack X tool and configure it to deploy to a brand new Linux host from Hetzner using Kamal and GitHub Actions, and then use the Kamal CLI locally to show some of the different commands you can perform to interact with your remotely running container. First, we will need to create a new application using the command xnew-blazor /myapp. This uses the servicestack.net X tool to create a new Blazor application with placeholders for using Kamal for deployment. Our goal is to get this application that runs locally now to be hosted on a new Linux server and accessible via our own domain name. First, let's start by setting up our Linux host. We'll be using Hetzner Cloud for this, as they provide excellent value for money. If you don't already have a Hetzner account, head over to hetzner.com and sign up. Once logged in to Hetzner Cloud, you can select your project, and here we've created a Kamal project. We can then click Create Resource, select Servers, and start to configure our Linux host. First, we will select the region where our server will be located, and then we will select one of the Ubuntu images for the base operating system. Next, we can choose our type of server. For this demo, we'll just select a shared x86 CPX11 server, which is currently priced at €424 per month. This is a 2 vCPU and 2GB memory setup, which will be plenty for our Blazor application. We also get 20 terabytes of traffic and 40 terabytes of local storage, again, which will be more than enough for this demo. And if we need to scale up in the future, larger instances available at very reasonable prices, going all the way up to 16 vCPUs and 32 gig of memory. While our server is being provisioned, let's set up our DNS. You'll need a domain name for this, and here we'll be using blazor-kamal.netcore.io for this demo. This process might differ a bit depending on which provider you use for DNS management, but generally the following steps should be pretty common. And they are logging into where you manage your domains, selecting the domain you want to manage, creating a new A record for the subdomain. Here we're using blazor-kamal, for example, which is then combined with netcore.io, which is the domain we have registered. Once your Hetzner server is ready and running, you will have an IPv4 address that you can copy and paste the IP into the A records value that you're creating in the DNS management. Save the DNS record and you should be ready to go. Hetzner does offer this service as well, but you can combine whichever hosting and domain management services you want. Next, we will need to create a deployment SSH key that will be used by our GitHub Actions. And we can do this with the SSH-keygen CLI utility. Here we're specifying the type of key and giving it a name that we can identify and an output address for where we're saving it. Now, I will have all these commands that are linked in the documentation in the description, so you can easily copy and paste them if you want to follow along. This is important, as generally private keys shouldn't leave the machine they're created on, so we want to create a dedicated deployment key since we need to populate a GitHub Actions secret with a valid SSH key. We will also need to add the key into the SSH authorized keys file on the remote server that you've just created via Hetzner. You can share the public key as a part of this key pair with Hetzner, so it automatically does this for you when you're creating a new server. But to do it manually, we just need to concatenate the .pub or public key component to the authorized keys file on the remote server on a new line and then save it. You could also configure a separate user on the remote server specifically for deployments as well for more isolation, but for the demo purposes, we are going to use the default root user. So what we've done so far is create a new virtual private server with Hetzner, configure our DNS to point to that server, and create an SSH key which will enable GitHub Actions to connect remotely with that server for deployments. So now that that's all ready, let's configure our application for deployment. Navigating to your MyApp directory locally and opening the config/deploy.yaml file, we need to update a few key settings. Here we will need to update image, the server's web IP address, and the proxy host URL. The IP address is the same that we've created for our new Hetzner server, and the host is the DNSA record you created that's been related to that same IP. The image is the path after github.com, since we're going to be using GitHub's package management domain of ghcr.io. So choose a repository name and which account you'll create it under, and then make it all lowercase, and you will have the value for the image property. Next, we will set up the GitHub repository and configure the secrets for automated deployment. If you created your Hetzner server first, you can also use the server stack templates to create your repository directly from the GitHub's web UI, navigating to the Net Core Templates organization, identifying which template you want to use, and on that repository page you will see a Use This Template button, and then you can make the changes to your deploy.yaml. Once that's done, we can then add the deployment key as a secret, again either via the UI on github.com or using the command ghsecret set ssh_private_key, piping in the deploy key file that we created earlier. And now our application is ready for its first deployment. Now let's push our code to the GitHub repository using git push-u origin main. When the code is pushed, it will trigger our GitHub action workflow, which will then build and test our application, create and push our Docker image to ghcr.io, use Kamal to initialize our Hetzner server to host our application, and deploy the application itself. While that application is deploying via GitHub Actions, let's have a look at some useful Kamal commands you can run locally. We have Kamal details, which shows us the details about all the containers running on the configured server. We have Kamal app logs, which will output the logs from your containered application. This can be extremely useful for trying to troubleshoot production issues and various other scenarios. And we have Kamal app boot for restarting your application. There are loads of different commands that Kamal wraps, which are extremely useful. So check out the Kamal deploy website for all the documentation there. And the great thing about how Kamal works is that if you have multiple applications deployed on multiple servers, you can run these commands from your specific application repository folder locally, and Kamal will use the context of that application's config when running, making it much easier to manage your self-hosted applications. Kamal also has a flexible way of handling secrets, rollbacks, and other common features, and because it wraps technology like SSH and Docker, this should create an extremely stable and productive toolset for self-hosting, so you can avoid large cloud costs when your applications just doesn't need to scale beyond the one machine. And there you have it. Your application should now be running at the domain you configured with automatic SSL certificates provisioned, handled by Kamal proxy. And just like with the previous Nginx reverse proxy setup, you can deploy multiple applications to the same server, and Kamal proxy will handle all the routing. Well, that's it for this video. If you have any questions or feedback about the use of Kamal in the templates, please let us know in the comments. Or you can join our community Discord and GitHub discussions. ServerStack is free for individuals and open source projects, so anyone is welcome. And as always, thanks for watching.